Welcome to AP Calculus. The quiz is 1 week from today. It covers sections 4.1 and 4.3. So it's going to cover antiderivatives and U substitutions. That's 1 week from today. We're going to be learning other things on block day this week and on Friday and Monday, but the next week's quiz goes up through today's material and then it stops. So here we go. The students here in the room, I've already told them to have the handout for antiderivatives. The first handout, 4.1 handout, because we are going to go back and fill in these antiderivatives, which had been TBD. Let's pick up where we left off on the U substitution lesson from yesterday with number 8. Now, number 8 seems to be quite confusing. If you try to let U equal x plus 3, it doesn't match, or it doesn't appear to match. Check this out. U equals x plus 3. If you make that attempt at a U substitution, du equals dx, it doesn't seem to work. We hit a roadblock. However, yeah, we do replace x plus 3 with u, so it's nicer to have a monomial than a binomial under the square root. But what do we do with, there's no x plus 3 up here. There's no easy way to get an x plus 3 up there. So when you run into what feels like a roadblock, consider this move. It's a third layer of substitution. Take the first equation and solve it for x. If u is x plus 3, then x can be replaced with u minus 3. It's a new layer in U substitutions. What does this do for us? Well, when we start taking inventory and say, okay, I'm going to replace x with the quantity u minus 3, minus 1. I'm going to replace the quantity x plus 3 with u, and dx, according to my translation guide, gets replaced with du. Yeah, it did work. I successfully changed the integrand, if you will, from an x-based integrand to a u-based integrand. But at this point, you still might be skeptical. You might be wondering, well, how is that any better in terms of complexity than what we had? Isn't it supposed to be less complicated after the u substitution? Well, here's why this is better than that. It's because under the square root, we have a monomial instead of a binomial. That's why this is preferred. In fact, where do we go with it? To find out, let's distribute the 2. Let's combine like terms in the numerator to get 2u minus 7 over the square root of u. And just like on the previous homework assignment, we can now distribute radical u to each of the 2 terms in the numerator. We have 2u over radical u minus 7 over radical u. And a move with which you're going to become quite familiar here in Unit 4 is a move in which you rewrite the antiderivative of the difference as the difference of the antiderivatives, while simultaneously pulling those constants, also known as scalar multiples, out through the semi-permeable membranes. We're just going to move right out. It's kind of like on the video, how my head is moving off the screen. My head is permeating the screen. So it's just passing through the edge of the screen. If you have trouble imagining that, just go home and watch the video. You'll see my head passing through the semi-permeable membrane of the side of the video screen. So here's how we do it. So we have, by the way, that's an effect, it's a special effect never before experienced in motion picture history. It's the semi-permeable membrane effect, represented by my head. Here we go. 2 antiderivative of u over radical u du minus 7 antiderivative of 1 over the square root of u du. Any questions on how I made the move from one integral to count them, 2 integrals. It's a double move because I also pulled the 2 out front through the semi-permeable membrane, also the 7. Try to finish it from here. We are now in familiar territory. Try to wrap it up. In case you're stuck, you can write this as 2u to the 3/2 over 3/2 minus 7u to the 1/2 over 1/2 plus that constant of integration. I would argue that the final answer is 4/3 times u, which happens to be x plus 3 to the 3/2 power, minus 14 times quantity x plus 3 to the 1/2 power plus a constant of integration. And when you red box the answer, will help you distinguish the final answer from the work that led to the final answer. Jen?
So the 2 you took out earlier doesn't affect the 7 at all?
Correct. I mean, it's separate terms. 2 affects this term. This first term is multiplied by 2. The second term is multiplied by 7. So that's a correct statement. I did the antiderivative of a difference is the difference of the antiderivatives, and then I also just pulled out the scalar multiples through the respective semi-permeable membranes for the questions. Yes, Crystal?
What do you set x equals to u minus 3?
I used it right here. It's the only place I used it, was I replaced that x with u minus 3.
Like, why is it u minus 3 though?
Because if u is x plus 3, then solve this equation for x. X must be u minus 3. Any other questions on this one? Now, this is more practice, time consuming. It actually uses row 3 of Pascal's triangle to expand it. If we have time for that, we'll come back. But it's just practice, not a new concept. Let's get some really exciting stuff on the next page. This is where things start to get interesting with U substitutions. Let's skip forward to number 10. Number 10. Now, number 10 is not a U substitution problem because when the 2 passes through the semi-permeable membrane, it is clear with no U substitution whatsoever that the answer must be what? Write down what you think the answer is to number 10. I'm just going to tour the room to see what sorts of things you come up with. Do number 10 together. Wesley, would you tell me what you believe the correct answer is for number 10?
2 natural log of the absolute value of x plus c.
I almost jumped up and down. But I only do that once per year. You remembered the absolute value on the x's. Not everyone remembers that. And thanks for saying plus c. Any questions on this one right here? Oh, by the way, since this was such a short problem, would you please insert a problem 10.5 into the lesson right here? And this will be a stroll down memory lane, antiderivative e to the 2x dx. Would someone briefly explain to me why is the answer not, and since this is not the correct answer, please don't write it down. Why is the answer not e to the 2x plus c? What mistake has been made? when,
Because I didn't have the derivative of the block, so it should have been.
yeah, I mean, this is a U substitution required problem. I mean, think about it. The very first derivative formula that you learned in your whole life was the derivative. This is unit 0 of calculus. The derivative of e to the x is e to the x. We have a formula for the derivative of e to the x. Therefore, we have a formula for the antiderivative of e to the x. The antiderivative of e to the x is e to the x plus a constant. But we don't have a formula for the derivative of e to the 2, or for the antiderivative of e to the 2x, which is why this is mistaken. It's a very common answer, by the way. I don't know if you can imagine anyone writing down this answer, but it's very common. What needs to be done instead is for a student to say u is 2x, du is who? What is it?
2.
It's not just 2.
2dx.
2dx. So doctor it up with a 2, counterbalance with a 1/2, and try to finish this problem on your own. When you're done, you can take a peek up here. If you're showing all your work, then end up with 1/2 e to the 2x plus c. If you don't believe it, you can take the derivative of this family. If you want to check, derivative of 1/2 e to the 2x is 1/2 e to the 2x times the derivative of the blob plus 0. 2's cancel, you get e to the 2x, sure enough. So, any questions on how to get the antiderivative of e to the 2x in problem 10.5, 1/2 e to the 2x plus c? You know what? I'll bet you can start doing these in your head. You could probably do one with your eyes closed, just about. In fact, I'll bet you can do this one with no work. I'm just going to call it problem 10.6, put it up here. What's the antiderivative of e to the sine x times cosine x dx? See if you're that good that you can do u substitutions in your head. By the way, what u substitution are you doing? What's u equal to? Sine x. So in your head, you've got u equals sine x. What's du? No. You're making it too hard.
Cosine x dx.
Cosine x dx. Whew. Cosine x dx.
Also,
U is sine x. Du is cosine x dx.
E to the u.
Just e to the u. What's the antiderivative of e to the u with respect to u?
e to the sine x plus c.
So it's e to the u plus c. Yeah, so you can do it in your head. That was just e to the sine x plus c. I mean, you don't have to do it in your head. You can write it down. But I'm saying these things, when they're pre-cooked, they're nice. They just flow right through. U substitutions are smooth. Oh. So, whether you do it in your head or not, the answer is e to the sine x plus c. Kind of nice, huh? Any questions on that little mini problem? Yes, go ahead.
Can you explain why e to the sine x plus c?
Well, if I were to show my work on this, I would say u is sine x, in which case what would du equal?
Negative cosine of it?
No, positive cosine x. Dx. Don't forget the dx, because then you have a perfect match. E to the u du. So when you're taking the antiderivative of e to the u du, what do you get? Using the letter u. Close. E to the u plus c. So the final answer is e to the sine x plus c. We good on that? All right. My guess is you'll be able to get to the point where you look at this and you say, oh yeah, it's e to the u, du matches up, it's just e to the u plus c. You'll get there. All right, number 11. I would strongly recommend that you let u equal 2x minus 1. See if you can finish it from there. Try number 11. I'm going to pause the camera, tour the room, and then we'll see what we came up with. This one. If you let u equal 2x minus 1, then tell me, class, what's du? Ready? Go.
2dx.
2dx. So let's doctor this problem up with the number 2, counterbalance with the 1/2. A little bit of glitchiness there, so those of you watching at home, you remember what to do. We just click save. Doctor it with the 2. With what do I counterbalance, friends? 1/2. So when I use the u substitution, I get 1/2 times the antiderivative of what? Help me out with this one, please, Will. 1 over u, there's more, du. So my next move is 1/2 natural log of the absolute value of u plus a constant. I hope your final answer was 1/2 natural log of the absolute value of 2x minus 1 plus the constant of integration. We red box the answer. Any questions on number 11? Yeah, go ahead.
So how do you know that du is equal to 2d?
Well, du, first of all, you're basically asking, how do I fill in the second line? I mean, it says du is 2dx. And I'd like everyone to hear this, so make sure you give UU the floor as he asks and gets questions answered. We talked about the mind bubble, or the mind cloud yesterday, the stuff that's going on in your mind. When you see u is 2x minus 1,
Oh yeah, never mind, I remember that.
you don't want me to finish u. You think
I remember.
I should just stop right now. Yeah, it's 2x minus 1 dx. And it's 2 dx. Okay.
Yeah, I just forgot that part. Yeah.
Just forgot. All right, good. Well, thanks for asking. You're probably not the only one who forgot. So, just one. Number 12. Now, problem 12. Just like on that homework problem, if you got a side conversation, go ahead and direct your attention up front. And distribute x to each term in the numerator. We've distributed square roots to each term in the numerator. Would you please attempt number 12 on your own? Please distribute, I mean, if you think, you know what, I'll be honest with you. A lot of students are going to look at this, because we're in a lesson on u substitutions, students will go the wrong direction. I just want to show you the wrong direction, because some of you might be thinking this. Oh, it's a u substitution lesson. Maybe I should let u equal x squared minus 4. Then this is not correct. I recommend you not write it down unless you like to write down examples of things to not do, which could be helpful. 2x dx. You might be thinking, oh yeah, I can do this. I can doctor with a 2, division by 2 can be counterbalanced with multiplication by 2. Here's the problem. Dx is always in the numerator. This is not 2x dx. This is dx over 2x. So it doesn't match up. It might look like it matches up. It doesn't match. That's why a u substitution is not the way to go. How many of you can see yourself thinking, oh yeah, I almost got deceived into thinking this was the way to go. Let u equal x squared minus 4. Does everyone think, yeah, see? That's why this example is in the lesson. Students sometimes use a u substitution even though it's not possible. Instead, just do what we've already learned how to do on the homework, and that is distribute the denominator to each term in the numerator. Try it. Try number 12 on your own. All right, when you're done, you can peek up here. I distributed the x to each term in the numerator. Upon simplification, I see that the antiderivative of a difference is the difference of the antiderivatives. 4 is a scalar multiple that sneaks out front. You shall not pass. Well, actually, I'm just a scalar multiple. I shall pass through the semi-permeable membrane. Balrog. 4 can pass through. Any questions on that? Just out of curiosity, how many of you came up with this on your own? You didn't even need to look at my notes. You just figured it out. That's great. Any questions on number 12? All right. Now, number 13. You want to do a u substitution on number 13? Do you think that'd be helpful?
Yeah.
If you were to do a u substitution on number 13, what would you let u equal?
Plus 1.
Yeah, just like we don't want to have a binomial under a square root symbol, we don't want to have a binomial squared. We'd rather have a monomial squared. So let's let u equal x plus 1. du is dx. Are we gonna be able to make this go? Ah.
1/2.
See what the next move is?
1/2.
X.
Solve it for x. This is one of those where you're gonna wanna solve the first equation for x is u minus 1. Okay, let's give it a go. Try number 13. It's one of those again. You can pause the camera, then we'll come back to it. And this is one of these more complicated u substitution problems. But the u version, I think, is 2 times the quantity u minus 1 over u squared du. And I'm totally fine with distributing the u squared to each term in the numerator. Because upon distribution, we have the antiderivative of a difference, which is the difference of the antiderivatives. I hope you see this going 2 times the antiderivative of, doesn't this collapse to 1 over u? Minus 2 times the antiderivative of 1 over u squared. Before I go any further, oops, I forgot my du right here, that's required. Any questions on how I was able to make it this far? I see this as 2 antiderivative of 1 over u minus 2 antiderivative of 1 over u squared. Right? So 2 natural log absolute value of u minus 2 times, are we okay with thinking this as u to the negative 2? Perhaps I should write it like this. I don't want to be doing stuff in my head where you can't follow it. So 1 over u squared is u to the negative 2. So I believe we're going to end up with 2 natural log absolute value u minus 2 u to the negative 1 over negative 1 plus c. Don't get tricked into thinking that's u to the negative 3 over negative 3. No, we add 1 to the exponent, divide by the new exponent. I think I can now get the final step, since u is x plus 1. Final answer, 2 natural log of the absolute value of x plus 1 minus 2. Oh, no, it's plus 2 because the negatives cancel. So it's 2 over x plus 1 plus c. You see, u to the negative 1 is 1 over u. And 1 over u is 1 over x plus 1. And I'm just going to pause here to make sure we're okay with number 13.
When do you need to solve for x?
You say, why did I solve that for x?
Like when?
When do you do it? Well, when you get frustrated. Like, look at what happens. Look at how frustrated you get when you don't solve for x. U is x plus 1. Du is dx. So I replace x plus 1 with u. And you got this x here. It's like, how am I going to get rid of the x? There's no way I can do it. Oh, unless I solve this for x. So when you get frustrated, consider solving the u equation for x. You got to be in touch with your emotions. It's like, oh, I'm feeling frustrated. What should I do about this? Solve for x. Jack, you okay?
I got it.
You got it? Are there any other questions on number 13? Looks like you're in good shape. Now, 14 looks scary, but if you make the right u substitution, it comes out nicely. What do you recommend we let u equal on number 14? All right, Elijah.
Natural log x.
Well, let's consider that. Is that a good idea? If u is natural log x, can someone give me the du expression? You?
I have a question about.
Oh, wait, hold on. Let's see if this fits first of all. If u is natural log x, what would du equal? Crystal?
1 over x
There's more to it.
dx.
1 over x dx. Wait a second. We have 1 over x dx. It's a perfect match. So that when you make the substitution, it becomes the antiderivative of what? What is this thing? If you replace natural log x with u and 1 over x dx with du, what does it become? What's the u version? Raise your hand if you think you see it. Okay, Jack.
So 1 over u.
1 over u du is correct. Go ahead and finish it up. Take it from here to the end. Did you get the natural log of the absolute value of the natural log of x plus c? Natural log of the absolute value of the natural log of x. This x does not have an absolute value around it directly. Raise your hand if that's what you came up with. Widespread, every group has at least one. So, pause here. Take any questions on how to get this. Eli, no, you said you got it right. Okay. Yes, you. Go ahead.
On number 13?
Yeah, number 13.
Would you have to take the 2 out? You could do it without taking the 2 out.
I didn't take the 2 out. I just replaced the x with the quantity u minus 1. So you're obligated to distribute the 2, right?
And then, like, at the over there, you factored out.
Oh yeah, always bring that scalar multiple out front. Bring this 2 out front, bring the other 2 out front.
Should we always do that?
Oh yeah, always bring out the scalar multiples. Let's go to our last page, page 4. Okay, class up. This is going to get pretty intense right here, but there's a story associated with it that might in fact capture your imagination. Matt, you ready for story time?
Yeah.
You think about the people who have wrestled over the centuries finding the antiderivative of secant x. I mean, we know the derivative of secant x is secant x tangent x. But what family of functions has a derivative of secant x? It doesn't seem like there's any that come to mind quickly. But it turns out that if you multiply secant x by the number 1, and it's a special form of the number 1. How many forms of the number 1 are there? Actually, there's 2 that come to mind. 5 divided by 5, that's a form of the number 1. Oh, there's another one. 12 divided by 12, that's equal to 1. How many are there altogether? There's an infinite forms. How about x divided by x? If x is not 0, is x over x equal to 1? Yeah, there's a lot of them. There's an infinite number of forms of the number 1. There is a form of the number 1 by which you can multiply secant x. And if you're thinking, oh, by the way, if you're thinking, oh yeah, I know, let's do 1 over cosine. This is not it. This won't work, because if you let u equal cosine x, du is negative sine x dx, which doesn't gel. It doesn't fit in. So this is not easy. But there is a form of the number 1 by which you can multiply secant x so that u substitution does work. Does anyone know what form of the number 1 will work? It's not 12 over 12. Will, do you know? Do you know what form works? When you see this, Jack, do you know? I know you've got some math talk going on there. Do you know what was going on when the person thought of this form of the number 1? I know I don't know, but I imagine what could possibly have been happening that caused a person to think of multiplying secant x by the number 1 in this form. Secant x plus tangent x over secant x plus tangent x dx. What could have happened in their mind that caused them to pick this one? I imagine it was a dark and stormy night. Rain pouring down. Can't sleep. Too much thunder. Light a candle. Let's see if we can come up with the antiderivative of secant x dx. Somehow this popped into that person's mind. It happened. There was a first time. And oh, do you guys have a question on the previous problem? Is that what you're working out, Jack? No? This is the dark and stormy night problem. It was 3:30 in the morning. Let's do this, because when you multiply by 1 in that form, you get antiderivative of distribute the secant x. You get secant squared x plus secant x tangent x over secant x plus tangent x dx. Notice that if you what might we let u equal? Does anyone have an idea of what we can let u equal in this green problem? Let's let u equal secant x plus tangent x. Let's let u equal the denominator, in which case du would equal what, Shriana? What's the derivative of secant x? Secant x tangent x plus secant squared x. There's more.
Oh, yes.
Dx. It's a perfect match. Secant squared x plus secant x tangent x dx. We don't even need to doctor it up. With this u substitution, it's antiderivative 1 over u du. Do you agree? Just 1 over u du. So we're going to write the natural log of the absolute value of u plus a constant, where u is secant x plus tangent x, then plus c. Let's take it back to the other handout. We finally discovered the antiderivative of secant x. It's the dark and stormy night formula. We're going to put it right here, except we got to use theta. So the antiderivative, okay, the derivative of secant theta is secant theta tangent theta. The antiderivative has now been derived. It's the natural log of the absolute value of secant theta plus tangent theta plus c. We used a u substitution with the dark and stormy night insight to get that one. By the way, just like you have, and I'm going to turn the camera to the sideboard, just like with derivatives, there's a negative sign pattern. You notice how the derivative of sine is cosine, tangent is secant squared, secant is secant tangent. So eyes over here to the sideboard. You get the derivatives of the cofunctions, just negative cofunction, negative cosecant squared, negative cosecant x cotangent x. The same pattern applies to antiderivatives. If you want to get, back on the other handout, for cosecant, you could go through the whole thing, but I'll just tell you right now, for cosecant, it's going to be negative natural log of the absolute value of the cofunctions. Cosecant x plus cotangent x plus c. I mean, you could do a similar derivation, but I just want you to know that pattern exists. So let's put that one back here. For cosecant, it's going to be negative natural log of the absolute value of cosecant theta plus cotangent theta plus c. Let's wrap it up with 2 examples, one tangent, and the other is a double u substitution. So let's go to our handout today and look at tangent. We don't have to do this one again. So we have only 2 more examples. For tangent x, think of tangent x as sine x divided by cosine x. Note that when you decide to let u equal cosine x, du would have to be negative sine x dx. That's as close to matching. We doctor with a negative sign, which I put here in green. Trying to put it in green. And then we counterbalance with what? A negative sign, that's right. So when we convert from x to u, we get the green negative sign times the antiderivative of 1 over u du, which is 1 over cosine x, which is u, and then du is negative sine x dx. So it's negative natural log of the absolute value of u plus c. That's another one that was to be derived. It's negative natural log of the absolute value of cosine x plus c. Let's take that to the other handout, and instead of to be derived, it is now known as negative natural log absolute value. So on the other handout, we put the final answer for tangent. It's negative natural log of the absolute value of cosine. I guess we have to use y here, plus c. And then for the cotangent, it's going to be positive natural log of the absolute value of sine y plus c. So we got all four of those that we said we could derive, and there's only one example remaining in this lesson. It's called the double U substitution. It's going to take us about 30 seconds past the bell. Just hang with me. Let's knock this out. We don't have to do number 20. It won't be on the quiz. It won't be on this test, but we will have to do ones like this. Note that if you let u equal 5x, du is 5 dx, we doctor with a 5 and counterbalance with a 1/5. Doctor with 5, counterbalance with 1/5 to give us 1/5 antiderivative of 1 over e to the u du. That may look undoable. However, I can rewrite it as antiderivative e to the negative u du. That's real progress. But it requires another, since negative u is a blob, I'm obligated.
Following students, please stop by the front office. Abby Jones, Jenny Marsteller, Josh Schauer, Jamal Freeman, please stop by the front office.
I'm obligated to let w, I can't use u again, so I'm going to let w be the blob. So dw is negative du, doctor with a negative, counterbalance with a negative, and finally I can take the
Would
antiderivative.
Henry McGowan please come to student services?
So finally, I can write that as e to the w. Antiderivative of e to the w, so it's negative 1/5 e to the w plus c. I've got to work my way all the way back to x, so I replace w with negative u, and then final answer, replace u with 5x. So final answer is negative 1/5 e to the negative 5x plus c. That completes our lesson on U substitution. The homework is due on Thursday. I'll leave it up there in case you need to take notes. You are dismissed.